In this small video, we will try to understand acceleration. So in the last session, we had seen that there are two types of motion, uniform motion and non-uniform motion. In non-uniform motion, the velocity of an object keeps on changing. If the change in velocity for every 1 second is constant, then that is uniformly accelerated motion. If the change in velocity changes like randomly, then it is a non-uniform acceleration. Generally, when they define, you will find this definition in most of the textbooks, like acceleration is rate of change of velocity. So what is rate of change of velocity? There is a word before that. We often write, when we write a number like it is 10, not 10 by 1, but the 1 is understood. Similarly, rate of here means time rate of. Time rate of means for every 1 second. For every 1 second. For every 1 second, change of velocity is called acceleration. How do you calculate that? Suppose you take the case of a 5th generation fighter jet, because I'm going to talk about a little bit high velocity. The speed of the jet was 0. Once they start the jet, within 4 seconds, the jet is now going with the speed of 160 meters per second. So in 4 seconds, the speed goes from 0 meter per second velocity to 160 meter per second velocity. If for 4 seconds this change in velocity is 160 meter per second, then for 1 second, how much it would have changed? Each second 40, 40, 40, 40, 160. How do you find that? It is 160 by 4 seconds. If you divide the change in velocity by the amount of time taken, that is equal to acceleration. Here acceleration of that jet has come out to be, for 160 by 4 is 40 meter per second by 1 second. This definition has come out, you see. For 1 second, how much change in velocity is taking place, that is called acceleration. Now comes to the formal approach. How do you generally write acceleration? At time t1, the object's velocity is v1. And you are observing the object, and slowly the time goes up to t2. After a while, when the time is t2, the velocity changes from v1 to v2. What is the duration? It is 6 o'clock when you observed, it was v1. 7 o'clock when you observed, it was v2. Then what is the time elapsed? It is 7 o'clock minus 6 o'clock. Similarly, t2 minus t1. So t2 minus t1. This is the time taken. In this time taken, how much velocity has changed? v2 minus v1. So this change in time, we often refer it as delta t. And the change in velocity, we refer it as delta v. For delta t seconds, delta v is the velocity. Then for 1 second, the change in velocity will be delta v by delta t. That delta v by delta t is called acceleration. Right? So how do we generally change that? You try to go through this once. I'm going to write it over here because I do not have screen to capture that. So acceleration is defined as change in velocity by the time taken. In other words, the change in velocity for every 1 second. So usually, to make the problem more understandable, universally we use two things. When you start observing an object, you will have a stop clock. When you turn on the stop clock, the time starts from 0. Similarly, this t1 is always taken as 0. And t2, whatever time shows, that is t. When you start from the scale 0 and goes up to 7th centimeter, the change in value is 7 minus 0. So 7. Similarly, start from 0, whatever time. So the time duration is t minus 0, which is t. So here instead of delta t, t2 minus t1, t minus 0, that becomes t. Universally, we use one notation for the beginning velocity or the initial velocity. Initial velocity here means when you start your observation, what is the velocity is called initial velocity. Suppose you are dropping an object. When you drop an object, at the instant of dropping the object's velocity is called initial velocity. When you are throwing an object, at the instant when the object leaves your hand, that is called initial velocity. So usually we use u as representing initial velocity, v as representing final velocity. Always the velocity changes from u to v. Then the change in velocity is final value minus initial value. Suppose you have 50 rupees and then after some time you collect some money, it becomes 200 rupees. What is the increase in value? 200 minus 50. So similarly here, change in value is v minus u. So v minus u. So acceleration is often referred to as v minus u by t. Here t is the time taken. There is no difference between t and delta t. The only difference here is t1 becomes 0, hence delta t becomes t. So acceleration is defined as the change in velocity for every 1 second or rate of change of velocity. So just like the previous example, there velocity is given in meter per second. So unit of acceleration is unit of change in velocity. If velocity's unit is meter per second, change in velocity is also meter per second. So it is meter per second by time taken is in second. In SI system, the unit of acceleration is, the second comes down, so second square. In SI system, the unit of acceleration is meter per second square. In CGS system, it is centimeter per second square. One last example to close the definition. The acceleration due to gravity of Earth. Earth is a huge mass. It is attracting all the objects down. If you drop anything, the Earth attracts with some force. Because of that, acceleration is produced. That acceleration is roughly 9.8 meter per second, or you can approximate it to be 10 meter per second square. That means if you drop an object, after 1 second, the velocity becomes 10 meter per second. After 2 seconds, it becomes 20 meter per second. But if you go to moon, that's why they performed this experiment on moon. Here, if you drop a feather and a hammer, in no time it will fall down. But on the surface of moon, gravity is very weak. It is only 1/5 that of the Earth. That means if you drop it, here Earth, it is 10 meter per second square. That means every 1 second, 10 meter per second velocity will change. On moon, it is only 1/5. That means roughly 2 meter per second square. That means if you drop it, every 1 second, velocity changes by only 2 meter per second. So if you drop a feather and a hammer, because there is no atmosphere, there is no air resistance, if you drop it, they recorded it. Maybe you can watch it in the YouTube searching using proper keywords. If you drop it, so they go very, very, very slowly. I hope I've made acceleration to a certain extent clear.